Hello everyone, welcome to a new lecture. In this video we are going to talk about the sun. This is a close-up picture of the sun. The sun is the center of the solar system. All the 8 planets that exist in the solar system revolve around the sun, and the reason is the sun is huge. The gravity of the sun causes all the other planets to revolve around it. The sun is a star, and the difference between a star and a planet is a star emits light, however a planet does not emit light. The sun is a perfect giant ball of hot plasma. The sun's volume is a million times that of Earth. So imagine how big Earth is. The volume of the sun is a million times of that. The sun's mass is about 330,000 times that of the Earth, and the sun accounts for 99.85% of the mass of the whole solar system. The sun is extremely hot. The sun's core temperature is about 50 million degrees Celsius. Most of the heat that we get on the Earth is from the sun. How far we are from the sun? Well, it takes 8 minutes and 19 seconds for light to reach Earth. The distance between the Earth and the sun is 1 astronomical unit, and it's about 150 million kilometers. It takes light 8 minutes and 19 seconds to go from the surface of the sun and reach the Earth. And the sun is the most important source of energy on Earth. Without the sun, life would not exist on Earth, because all the plants take the sun's energy, they convert them into food, and other animals eat them, and we eat them too. So without the energy of the sun, we would not live. Therefore, sun is the most important source of energy. And lastly, the diameter of the sun is about 109 times that of the Earth, so it's extremely big. These are some of the characteristics that can go under the definition of the sun. It is the center of the solar system. It is the most important source of energy. It is extremely big. It accounts for 99.85 mass percent of the solar system. The volume of it is a million times that of the Earth. The mass of it is 330,000 times of the Earth. It is 1 astronomical unit away from the Earth, which for light it takes 8 minutes and 90 seconds for light to go from the surface of the sun to reach Earth, and it's a perfect giant ball of hot plasma. Okay, so what is plasma? Well, plasma is one of 4 fundamental states of matter, and it is ionized gas. The sun is mostly composed of hot ionized hydrogen and helium. So basically plasma is ionized gas. Well, what does this mean? Well, the coolest state of matter is solid state. If you heat up a solid object, it will turn into liquid. If you heat up a liquid object, it will turn into gas. But what happens if you heat up gas? Well, it turns into ionized gas. You have seen plasma. The neon lights that you see, that's plasma actually. And the entire sun is made out of plasma, or it's made out of ionized hydrogen and helium. We have very small percent of neon, carbon and oxygen and other gases, but the majority of the sun is composed of hydrogen and helium. Actually, it's composed of ionized hydrogen and helium. Okay, so now we know what the sun is made out of, but what is the structure of the sun? Well, the sun is composed of 6 major layers. It is the core, the radioactive zone, the convection zone, the photosphere, the chromosphere, and the corona. These are the layers that compose the sun. The first one, the core, or the sun's core, is the central region where nuclear reaction that turns hydrogen to helium happens. The core has a temperature of about 50 million Celsius, comparing to the surface temperature of the sun, which is about 5,500 Celsius. So the core is about 50 million Celsius. The surface of the sun is about 5,500. There's a huge difference. Also, the region of the core extends from the very center of the sun to about 20 to 25% of the solar radius. And as I mentioned, the core of the sun is where nuclear fusion happens, the process where hydrogen turns to helium. Then we have the radioactive zone. This zone is about 0.8 of the solar radius, and it's the zone where energy gets transferred. The more we get away from the core into the radioactive zone and getting away from the boundary between the core and the radioactive zone, the temperature decreases. Then we have the convection zone. This zone extends from a depth of 200,000 kilometers up to the visible surface of the sun. This zone is characterized by the fact that on the surface of it, photons or light is created. So on the surface of the convection zone is where photons or light is created. Then we have the photosphere. The photosphere is the deepest layer of the sun that we can observe directly. It reaches from the surface visible at the center of the solar disk to about 250 miles, which is about 400 kilometers above that. The temperature in this region is about 6,000 and 4,000 Celsius. Then we get the chromosphere. This region is a layer in the sun between 250 miles and 1,300 miles above the solar surface. The temperature in this region is about 4,000 and 7,700 Celsius. So in this layer, it actually gets hotter if you go further away from the sun, unlike in the lower layers where it gets hotter if you go closer to the center of the sun. Then we get the corona. The corona is the outermost layer of the sun, starting about 1300 miles, which is about 2100 kilometers above the solar surface. The temperature in this region is about 500,000 degrees Celsius. The corona is a region that is special because it cannot be seen by naked eye, but actually we can see it during solar eclipses or with the use of coronagraph. So these are the layers of the sun. We have the core, the radioactive zone, convection zone, the photosphere, the chromosphere, the corona, and each have their own properties. And lastly, this is the size of the sun comparing to the planets. As you can see, this is Jupiter, and this tiny dot, this is Earth. So you can see how small Earth is comparing to the sun. The sun is huge. It has huge volume. It has a huge mass. It has a huge size. And it is because of its size and its gravity that makes all the planets revolve around it. And with this, we come to the end of our lecture. To recap,